Welcome back, everyone. Moving on to another example over here. We have to find the horizontal and vertical asymptotes for each of these functions here. So starting with number one, we got f of x equals 4 minus 3x all over x minus 2. So I'm actually going to start with the vertical asymptote. And how do we find the vertical asymptote? Well, vertical asymptote is going to be the x value that makes the denominator equal to 0. Because we can't be dividing by 0. If we're dividing by 0, it's going to be undefined, which is going to mean that there's a vertical asymptote at that x value. Now, there's a certain point I want to make about this here, x value that makes the denominator equal to 0, as long as the numerator does not equal 0. Okay, so you'll have a vertical asymptote whenever you have some kind of number over 0. When you plug in that specific x value, if you get 0 in the denominator and then you have a number up top, then that's going to be a vertical asymptote. But if you end up getting the result 0 over 0, that means that there's going to be a hole at that x value, and you're actually going to see that happen in number 3. Notice if we plug in -1 here into the denominator and then up here, the numerator and the denominator are both going to be 0. And that means there's going to be a hole there, not a vertical asymptote. So thought I would mention that, but I'll explain it a little further when we get to number 3. So number 1, notice the first thing you always want to do with these is factor them. So make sure that the numerator is factored and then the denominator is factored if you're given polynomial functions. For number 4, it's going to be a little bit different because we're dealing with exponential functions within a rational function. But here we're dealing with polynomials, so make sure they're factored. Notice 4 minus 3x over x minus 2, we can't factor those. Those are already factored. So the vertical asymptote for this function is basically going to happen when x minus 2, that denominator is going to equal 0. That's going to happen at an x value of 2. So x equals 2 is the vertical asymptote for this function here. Right, so vertical asymptote, that happens when the denominator is equal to 0. What about the horizontal asymptote? Now the horizontal asymptote happens as x approaches plus or minus infinity of a function. In this case of 4 minus 3x over x minus 2. Remember, limits at infinity give us horizontal asymptotes for functions, because as x goes towards positive infinity or negative infinity, if they approach a certain y value out in those ends, then that's the horizontal asymptote. So how do we do that for something like this? Well, we divide everything by x to the power of the highest exponent in the denominator. Notice that it is x to the power 1 in this case, because this is a constant. So we would plus or minus infinity, so we would divide the 4 by x, the 3x by x, the x by x, and then the 2 by x. Then notice these x's cancel out, these x's cancel out, we're left with a 1 here. And then this is going to go towards 0, and then this is going to go towards 0. So we'll be left with -3 over 1, which is just -3. So y equals -3 is the horizontal asymptote for this function. Another point I want to make is that when you're dealing with polynomial functions over another polynomial, the limit as x approaches positive infinity and negative infinity are usually going to be the same. So notice if we did the positive infinity just by itself and then we did the same thing with negative infinity, we would get that same answer of -3. But when we have other types of functions like these here, where it's not polynomial functions in the numerator and denominator, you're going to see in this function, number 4, we're going to have to actually do the plus and minus infinity separately because they're going to give us different answers. There's actually going to be 2 horizontal asymptotes for this function, number 4. Right? So I thought I would make a note of that. But when you're dealing with polynomials, plus or minus infinity, that limit at infinity is going to yield you that same result. Right? So that's the answer for number 1. What about number 2? What do we got here? We have f of x equals x squared plus x minus 12 over 2x squared minus x minus 3. First thing you want to do is factor these. So notice x squared plus x minus 12, that factors to x plus 4 times x minus 3. And then 2x squared minus x minus 3, that would factor into, we would have what? Minus 3 plus 1? I think that works out. Yes, it does. Okay, so that's the first thing you want to do, because the reason why you want to factor is sometimes factors are going to cancel out, and when they cancel out, that means that there's a hole there. So that's going to be an x value that makes both the numerator and the denominator 0, so that means there's going to be a hole there. In this case, that's not happening, but as I mentioned in number 3, that's going to happen. So nothing cancels out here, so notice how this function is going to have 2 vertical asymptotes. One when 2x minus 3 is going to equal 0, and when x plus 1 equals 0. So if we isolate for x, 3 over 2, here x equals negative 1. 2 vertical asymptotes here. So 2 x values that are going to make the denominator equal to 0. Because if this whole bracket is 0, the whole denominator is 0. If this bracket is 0, whole denominator is 0. Right? So those are the 2 vertical asymptotes. Now, what about the horizontal asymptotes? Well, that's going to happen when the limit as x approaches plus or minus infinity of this function here. And you actually want to write out the original function, not the factored one, because it's a lot easier to work with, in my opinion, with the methods that we've done in previous videos when stuff is not factored. So we'll have x squared plus x minus 12 over 2x squared minus x minus 3. Notice if we divide everything by x to the highest exponent is 2. Okay, so we could rewrite this. X goes towards plus or minus infinity of x squared over x squared plus x over x squared minus 12 over x squared all over 2x squared over x squared minus x over x squared and then minus 3 over x squared. Notice these cancel out. There's just a 1 left. X over x squared, that simplifies to 1 over x. These x squareds cancel out, so there's a 2 left. And then x over x squared again simplifies to 1 over x. So as x goes towards plus or minus infinity, remember a constant over x to the power of r, that's always going to go towards 0. We're going to have 0, 0, 0, 0. So we'll be left with 1 over 2. And that is going to be the horizontal asymptote as x goes towards positive infinity and negative infinity for this function number 2. And then moving on to function number 3, we got 2x cubed minus 2x all over x to the power of 3 plus 8 times x plus 1. Remember, we had a 4th function as well. I'll write that once we get to it. So first thing to do here is you want to factor. So notice how we could factor the numerator. So let me actually do that on this side here, so we're not taking up too many lines with this entire function. So 2x cubed minus 2x, notice we could take out a 2x. We'd have x squared minus 1 left. And then notice x squared minus 1, that factors into x plus 1, x minus 1. That's a difference of squares. So we could rewrite this function here as 2x, x plus 1 times x minus 1 all over x to the power 3 plus 8 all over x plus 1. And now notice that x plus 1's cancel out. And so what that means is that since that factor cancels out in the numerator and denominator, it means that at that x value of -1, which makes both of those factors equal to 0, there is a hole there. Okay, so it's not a vertical asymptote, it's a hole, because it's an x value that makes the numerator and the denominator equal to 0, if you remember from advanced functions. Okay, so just be careful with these kinds of questions where you may get a hole and not a vertical asymptote. So not all x values that make the denominator equal to 0 are going to be vertical asymptotes. So after those cancel out, the simplified function is going to be 2x times x minus 1 over x to the power 3 plus 8. Now notice that x to the power 3 plus 8, you could factor that. That's a sum of cubes. So if I take that, write it up here, got x to the 3 plus 8. Now for a sum of cubes, what's the formula? Just to do a little review, if you have a to the power 3 plus b to the power 3, that's going to be a plus b times a squared minus ab plus b squared. So this x to the power 3 plus 8, we could change that to x to the power 3 plus 2 to the power 3, right? 8 is the same as 2 to the power 3, and notice that this a value is x, this b value is 2. So if we plug in that respective a and b value, x and 2, here on the right side, we'd end up with x plus 2 times x squared minus 2x plus 4. Okay, so this function, we got 2x, x minus 1, all over x plus 2, x squared minus 2x plus 4. And then this bracket here, we can't factor that any further. Notice nothing else cancels out, so from here, we can tell vertical asymptote, it's going to happen at an x value of -2. Basically this bracket over here. And remember that x value -1 was a hole. Right? But notice -2 is not going to make the numerator equal to 0. So we're going to have a number over 0, means it's the vertical asymptote. Here, this bracket, there's no x value. That's going to make that 0. If you want to try to throw that in the quadratic formula, you'd get an undefined answer in your calculator. The square root is going to be negative in the quadratic formula. Okay, so that's the vertical asymptote. Now, what's the horizontal asymptote? So the limit as x approaches plus or minus infinity. Now, a couple of things we can do. We can use this original function that we were given, or we can use this simplified function, which in my opinion is better to use after this x plus 1 cancels out. Because the vertical asymptote for this is going to be the exact same as the vertical asymptote for that. That x plus 1 is not going to be really relevant, that x value of -1, as x goes towards positive infinity and negative infinity. And like I said, when you're finding these limits at infinity, I would have everything expanded if possible. So if you're going to do it up here, I would expand all of this, FOIL it out, but it's going to take a lot of work for that one. I feel like it's easier here. So if we expand this, we got 2x squared minus 2x all over x to the power 3 plus 8. Divide everything by x to the highest exponent in the denominator, which is x to the 3. So the 2x squared, that gets divided by x to the 3. The 2x, that gets divided by x to the 3. We got x to the 3 divided by x to the 3 plus 8 over x to the 3. So we'll have limit as x approaches plus or minus infinity. This, so we'll have 2 over x minus this, 2 over x squared over this, that would just be 1 plus 8 over x to the 3. And now notice that this is going to go towards 0, this is going to go towards 0, this is going to go towards 0. So we'll end up having 0 over 1 plus 0, which 0 divided by a number just gives us 0. And so the horizontal asymptote for this function is y is equal to 0. That's the limit as x approaches plus or minus infinity. And then finally, function number 4, we got f of x equals 2e to the x over 4e to the x minus 9. So this one's kind of unique because we're not having polynomial functions in the numerator and denominator. Notice we have exponential functions. But the same sort of methodology, that general methodology applies. So vertical asymptote, when's that going to happen? When the denominator is equal to 0. Okay, notice that you can't factor this either, so there's not going to be anything that cancels out. We don't have to worry about any holes in this case. But for the vertical asymptote, it's going to happen when this entire expression is equal to 0. So at what x value? Let's isolate for that x. So we got 4e to the x equals 9. The negative 9 we brought over became positive 9. Then we got e to the x equals 9 over 4. Divide both sides by 4. And remember, whenever you have e to the x equals, let's say y, and we want to isolate for the x, we just ln both sides. Right? So if we apply that here, we got e to the x equals y, but instead of y, we have this number 9 over 4. X equals ln of 9 over 4. Okay, so that is where the vertical asymptote is going to happen as an exact value, and if you plug that into your calculator, you get approximately 0.81. Okay, so at that x value, that's where a vertical asymptote is happening for this function. Now, what about the horizontal asymptote? As I mentioned earlier in the video, because we're not dealing with polynomial functions in the numerator and denominator, we can't just kind of group those limits at infinity at plus and minus infinity. We have to do them separately. Because if you remember, e to the x, it looks like that. So the limit as x approaches infinity of e to the x is equal to infinity. The y values are going towards infinity. But the limit as x approaches negative infinity of e to the x, it's going towards 0. The y values are going towards 0. And that's going to be important for this here. So we got to do two separate limits here. So for the horizontal asymptote, let's do limit as x approaches positive infinity first. So we got 2e to the x over 4e to the x minus 9. Notice this is going to go towards infinity, that's going to go towards infinity, so we have to do a little bit more work to show what's it actually going to go towards. So we could divide everything by e to the x. So this 2e to the x gets divided by e to the x. This 4e to the x gets divided by e to the x, and then this 9 gets divided by e to the x. These cancel out. So we'd have the limit as x approaches infinity of 2 over 4 minus 9e to the x. And now notice 9 over e to the x, as x goes towards positive infinity, that denominator there is going to go towards infinity. 9 over infinity, that's going to go towards 0. And so we'd be left with 2 over 4, which is 1 over 2. So that's the horizontal asymptote. But that's the horizontal asymptote, y equals 1 over 2, when x approaches positive infinity. There's going to be a different horizontal asymptote as we approach negative infinity. But as we approach positive infinity, it's 1 over 2. What's it going to be when we approach negative infinity? So let's change this limit here to negative infinity. Well, the limit as x approaches negative infinity of e to the x is just 0. So we can plug in 0 here, we could plug in 0 here. We don't have to do any further work. So we would have 2 times 0 over 4 times 0 minus 9, which would be 0 over 0 minus 9, which would be 0 over negative 9, which would be 0. All right, and so that is the horizontal asymptote for this function, y equals 0, as x approaches negative infinity. So there are 2 horizontal asymptotes for this function. So just be careful with these kinds of functions. Sometimes you can't just do plus and minus infinity. It's not going to give you that same answer, that same y value. They may approach different y values. So if you're not dealing with polynomial functions within a rational function, then just be careful because stuff can get a little bit more tricky.